welcome.
Thank you. So I'll start with a question as well. Who here has used a smart contract? Okay, that's a lot. All right. I bet it's actually more than that. Next. What is a smart contract? It is software that enforces the terms of a contract-like arrangement between third parties, right? So software that has a contract expressed in code, right, that enforces those terms. So I worked on the first production smart contract back in 1989. By the way, I'm Dean Tribble, I'm CEO of Agoric, and I've been working on some of this technology for a long time. And this doesn't say anything about blockchain. It doesn't say anything about Ethereum. It doesn't say anything about language. What it says is about the relationships between people, right? It's software that is enabling strangers to cooperate in new ways. And where this first started was, eBay, PayPal, Venmo, Airbnb, Uber, Lyft, all these things were trillion-dollar market cap before blockchain ever came along. What blockchain does, it gives us a trustworthy medium where we can run smart contract businesses without a trusted intermediary, without relying on eBay to give us our money when we've actually completed the sale, without relying on StubHub to not take a choice ticket and sell it to some executive in order to get a future favor, right? Not that they've done that, but it's easy to see how centralized actors can end up doing that. So smart contracts running on a high-value, high-integrity substrate of blockchain is an enabling ability for the future economy to move forward. But how do you build it, right? I mean, we heard even with Cosmos, they have trouble, there's challenges. You've got Solidity. They like to claim that it's just like JavaScript because it used curly braces. So it's just like C, and it's just like C++, and Java, and every other language that use curly braces. But other than that, it has nothing in common, right? And so you need to use new languages, and you need to learn them before you can do anything, right? They have, the Cosmos presentation, right? We talked about reentrancy. Billions of dollars lost to reentrancy bugs that are native security hazards intrinsic to the EVM model. Right? There's people do a lot of work to get around it, but humans just can't do a great job at that. So you've got these hazardous infrastructures. You've got poor tooling, where they're very excited about the stuff that they get there, but compare it to VS Code or WebStorm or any of these typical tools that people in Web 2 are used to, and the tooling has still got a long way to go. And then finally, of course, there's a limited developer pool, right? There's Electric Capital reports that there are 6,000 developers that can do a credible job of building a smart contract on Ethereum. Now, there are 100,000 that have been exposed to it, but 6,000 that can do a credible job. Compare that with 14 million JavaScript developers, of which it may be that only 8 million can do a credible job of building an application, but that's 4 orders of magnitude more developers that can build real applications on these things. So, and by the way, I wave my hands a lot, but when I do this, it's to go to the next slide. So, if you could take, and I saw several hands, but what was interesting is I didn't see as many hands as actually are people here who have probably programmed in JavaScript. It just might not be their core language, but 80% of the developers on the planet program in JavaScript at one point or another. So if you could take that skill set and use it to build a decentralized app, that then enables you, but it enables millions of people to be able to build these applications. And when you look at, right now we've got relatively small number of applications because we have a relatively small number of developers. And what that means is that you have, that until we unlock the much larger capacity of developers out there, you won't get local applications or, the dog-sitting business that could use a smart contract to orchestrate among decentralized people that will do dog-sitting and dog-walking, but you're not going to get that built by someone who's a dog enthusiast, which turns out to go viral and change how people orchestrate their pets, right? There's one of these things that you get opportunities created by having lots of people build lots of things, and that's the future that we expect to get to. It's not where we're at right now. So, How do you do this? How do you apply these tools? Well, that's where Agoric comes in, as a few people talked about, and I'll focus on Agoric in my presentation, but let me be clear. Cosmos is there, IBC is there, and we'll talk a little bit about it. So Agoric is a smart contract platform built on Cosmos SDK for being able to natively write smart contracts in JavaScript, specifically hardened JavaScript. We'll talk about that in a little bit. But it's not just about JavaScript, right? JavaScript is not the #1 language on the planet, right? It's not just that because of the language. It's that because it enables you to build strong frameworks, composable frameworks that let you take components and reuse them and put them together. So we'll talk a little bit about that. And of course, we natively integrate into the JavaScript async model, all these things like addressing reentrancy, like asynchronous access to other chains over IBC and so forth. Next. So what are the layers, right? Several people talked about layers. I have the advantages, of course, of having slides here, which is really nice. But we have Cosmos, Comet BFT, not tender, right? Cosmos at the bottom layer. But one of the cool things about Cosmos is you can build up from there, right? So on top of that is the Agoric JavaScript VM. This has distributed asynchronous messaging, deterministic execution, checkpointing and restart, replay, so we can replay a contract from the beginning and get to exactly the same state on a different machine. All these wonderful things that have taken literally years to build, or in some cases decades to build, to get to the point where we could do robust, confined JavaScript computation. And we've had people in the JavaScript standards committees for 15 years in order to get to this point. And then on top of that is that framework I talked about, is the framework where in React, you have affordances for mouse clicks and rendering and rapid UI development. In the Zoe framework, you have safety features for automatically escrowing assets and making sure that clients of a contract either get what they want or they get their money back regardless of the behavior of the code of the smart contract. So you have all these things that reduce the risk and speed safe development and reuse of components for building smart contracts. Above that, we have the economic backbone of the Agoric ecosystem, which is IST, Interstable Token. And that started as the core fee token for Agoric, right? It's a dual token system. We've got Build, the staking token at the bottom that works just like Atom in Cosmos or Osmo in Osmosis. And then we have IST, which is a dollar parity stable token that is used to pay for execution. Right? One of the things that people are only now starting to realize when you look at these platforms like Ethereum is I pay ETH for execution. ETH is a very volatile commodity, and yet I'm paying the thing that's sort of equivalent to my business rent. Right? You could pay your rent in Google shares or Apple shares or gold, but people learned a few thousand years ago, well, maybe only 1,000 or so years ago, that wasn't a great economy, that you're much better off having a stable currency to pay things so you can tell that your rent is the same next month as it was last month, as opposed to, oh, that token dropped it went up by a bunch, and now my long-term contract, I'm paying you 10 times as much as I thought I would. That's not great. You want the payment for gas, the payment for fees to be in a stable currency. And so IST has that natively. All of those contracts are built in JavaScript on the platform, running on the platform. But we rolled that out actually when we started talking to people about that at Cosmoverse a couple of years ago. We realized that being able to have a stable token that was backed by assets in the Cosmos ecosystem, by Atom, STAtom, Osmo, all those kinds of things, would be hugely valuable to the Cosmos ecosystem generally and to the interchain ecosystem generally. And so given that our platform is all natively, IBC integrated and all that sort of thing, that currency is not just a fee token for Agoric, it's now a fee token that you can use on Osmosis, on Omniflix, and on a few others. So it's growing to be a general stable token for use across the interchain. And then on top of that is, of course, all the stuff that you build, all the stuff that people are building on Agoric, not just dApps themselves, but also reusable components. Next. So some of those components, right? Lending protocols, a liquidity position, stop loss for multiple AMMs, NFT marketplace. There's an NFT character builder launching soon I'll talk about. All these components. Next. And each component is built in JavaScript, right? Just like a React component, it's a single file, JavaScript module, it exports a function, and that function takes an object, in this case called ZCF, the Zoe contract facet, and it registers, here's the JavaScript function I want you to run when a seller adds something to the auction, or when a bidder makes a bid. And so that's all deeply wired into this usable JavaScript programming API that just is kind of what programmers expect. Next. And on top of that, you get, of course, the best-in-class tools, right? So one of our investors a long time ago said, well, what's your development environment going to be? Because there's these things that people are starting to build for Solidity, and they're looking kind of good, like we're, somewhere only 10 years behind mainstream. It's just like, well, Microsoft spent $90 million or whatever it is building VS Code. We'll use that, right? The #1 development environment on the planet. So, you get, and I don't have these slides here, but you get pop-up help, you get types, you get command completion, you get Copilot integration, all the things that developers are getting used to, you get to use while building JavaScript apps in this environment. And the other thing is, blockchains divide up their execution typically into little chunks that you need to execute in a block. And if you want something that spans more than a block, that is asynchronous to the outside world, that sends a message to another chain, it's a nightmare. You go from being able to write simply to now you have to orchestrate state machines and manage all sorts of stuff manually to be able to manage those asynchronous interactions. And in Agoric, it's JavaScript, right? JavaScript has a wait. We can do async await in order to have a long-lived contract that's orchestrating multiple actions over IBC with multiple chains. You end up with much more natural programming models, again, with all the standard tools. Next. Oh, actually, go back one. So, and I did mention hardened JavaScript. That's another element. Hardened JavaScript, which you'll see in various places, and it shows up, it's not just Agoric, it's standards track, it's in embedded systems. It is basically the JavaScript you thought you were programming in, right? JavaScript at its heart is more mutable than you would normally want for applications you're going to rely on. Hardened JavaScript locks down that mutability, so you're programming in the language that the spec identifies, right? Next. So, how were these built, right? All of those things, IST, the platform, are all about building components. And how does a developer get involved? So this is just one particular developer journey. Joe, who's working on Calypso, he has a background in Node. He started with an Agoric bounty, right? We have several Agoric bounties out. There's a continual rolling things where they are interesting, right? They're useful components that could be used by other businesses and multiple businesses on chain. And we get those started in order to plant seeds. And that seed grew into, he got the model, he got the framework, he took the same ideas and applied them to the Cosmos Snap. So the Atom Accelerator funded in June, and it got released in September with the MetaMask Snap infrastructure. By the way, the MetaMask Snap infrastructure is all based on that hardened JavaScript, that JavaScript confinement kernel that we built in order to be able to do smart contracts in JavaScript. And then he went from there to build an application that is single machine, on the JavaScript engine, be able to do a portfolio manager cross-chain for your assets on multiple chains, all written in JavaScript. So that was one learning journey. But we've had several people building projects. Next. So, next slide. Oh, there we go. Yes. So, of course, we have the Interprotocol, which is a bunch of Agoric folks, as well as several people outside Agoric, putting together this live interchain-based stable token with multiple means of minting. So, parity stability module, MakerDAO style vaults. People are looking at other things for LP tokens, that sort of stuff. And, Zucky talked about STAtom. There are proposals now from the community to integrate STAtom as collateral and integrate Noble USDC and Kava USDT. So the community is active, the platform is growing, and it's something that leverages the Agoric platform ability to have an extensible framework and an extensible environment. Launching 9 p.m. tonight, I don't know, something, launching in the next couple of days for Cosmoverse you do know that Cosmoverse is happening, right? Launching is Cread, which is a dynamic NFT platform, and I could talk for hours about that, but instead you can come see them over this week. They're all in Istanbul and showing up at various events, as are folks from Calypso. I mentioned that, the interchain trading terminal that can access not just mechanisms over IBC, but it can use Gravity and Axelar and various other bridge technologies to access Avalanche and Filecoin and ETH assets and so forth. So you get this one-click orchestration of finances across multiple chains. And then finally, Tribble, which is an NFT lending marketplace. And that's not, let me borrow money against my NFT. That's, let me take my sophisticated NFT and lend it to you so you can get the discount on the soccer game tickets or whatever it is, right? Next. So these are apps that people are building on Agoric. As I said, you do know Cosmoverse is happening. By the way, it's awesome that you all came here. If you are at Cosmoverse, we have a room where the people that are building these things, or that have built these things rather, will be there to talk about how they did it, what the architecture is like, answer your questions about what development on the tool is like, and of course, we will also be there to help get developers set up or talk to you about your business and your work. So if you're there, absolutely come join us. Next. If you are a developer, after Cosmoverse, we have a dev day where they will also show up and present more specifically about those projects. So whip out your cameras, take the QR code. No, we can find you afterwards if you want to come. But sign up for that. And so we'd be very excited to have you. And next, so thank you for listening. If you are a developer or you just want to see what that architecture is like, go to the documents page. That'll get you started and give you all the ways into the Agoric ecosystem. Thank you.
Do we have any question? Yes, we have over there.
Dean, can I await an IBC packet? And how does that work?
So, there is a thing we call dynamic IBC that we realized when rolling out IBC, these many years ago, no, I guess a year and a half, that upgrading one chain with a new application protocol means that you can talk to nobody because they don't have the other side of the application protocol on there. And so dynamic IBC is, I'm gonna, upgrade Osmosis with a new application protocol, and now how do I get another chain to follow course? Well, on Agoric, you can then just load a JavaScript contract that can talk that protocol. The way IBC surfaces into JavaScript is indeed you can await that. In fact, I've shown code samples at other things where you can send an ICA packet and you get back a promise, right? Normal, standard JavaScript promise. You await that. And if there was an error with your message, it throws normally like you would do in await. And otherwise, you get the answer back from this message that went across and executed on some non-JavaScript train, right, on Osmosis or Akash or what have you. And the answer comes back, and now your JavaScript program can continue. And so your JavaScript running contract is just sitting there, swapped out, of course, waiting for this answer to come back over IBC in either an acknowledgement form, depending on the protocol, or as a response message. And so people are starting to add layers on top of these IBC protocols to provide the convenient JavaScript experience for it. If it's a send message and get an ACK immediately, great, that's easy, that's automatically supported. If it's a send message and then somewhere later down there's going to be a message coming back that I'm supposed to respond to, that depends on how people define their application protocol, then that works as well, right? If I say, send me Oracle notifications when this thing happens, great, and now the ACK is, yep, done, okay, and then eventually there'll be a message coming back and that'll resolve my promise. So yes, absolutely you can do that.
Thank you so much. And I would like to have an applause for Dean. Yeah.
Thank you.